Assalamu alaikum, all viewers and dear student. Today we have a new proof. Variance of x bar is equal to sigma square divided by n with replacement case. This is very important for BA, BC and BBA and MCS. Let's come we start. We want to show that variance of x bar is equal to sigma square x bar is equal to sigma square divided by n with replacement case. Now we are using the according to the definition of variance of x. Variance of x, we can write variance of x bar is equal to expected value of x bar minus mu whole square. Now we expand this term expected value of, we can write x bar is equal to I is equal to 1 up to n xi divided by n minus mu whole square. Now we taking LCM here, expected value of summation I is equal to 1 up to n xi minus n mu divided by n whole square. In replace of n, we change this term into summation. Expected value of summation I is equal to 1 up to n xi minus summation I is equal to 1 up to n mu whole square divided by n. Now this term 1 divided by n, I already here, this is whole square, and we common this term 1 over n square. Expected value of summation is also common from here. We can write summation I is equal to 1 up to n xi minus mu whole square. Now we are using also summation and also a minus b whole square formula we can use here. And also if we put the first term x1 x2 up to so on, and also summation we can also use, we can write here the first term 1 over n square expected value of the first value I is equal to 1 if we put x1 minus mu plus x2 minus mu plus up to so on plus xn minus mu whole square. According to the formula a minus b whole square, if we are use here uh, here 1 divided by n square expected value of x1 whole square plus expected value of, no sorry, x minus 2 whole square plus up to so on plus xn minus mu whole square plus 2n2 ab x1 minus mu n2 x2 minus mu up plus 2 x2 minus mu n2 x3 minus mu up to so on plus 2 xn minus 1 minus mu n2 xn minus mu. In the last term we will get here this according, if we expand a square plus b square plus 2ab plus 2abc plus 2ca up to so on. Now look here, from the first term up to this term, we can write here summation, we change this term 1 over variance of x bar is equal to 1 divided by n square expected value of summation I is equal to 1 up to n x I minus me whole square. If we put in the place of from this term to up to this term, we change here summation plus change into sigma. And here also here we get, and the product term 2 is taking common from each term. So we can also change this term into summation. We can write here plus 2 summation I less than j, because here the term is 1 is reduces here. So up to n x I minus mu and to x j minus mu. Now this is the covariance term. We can write this covariance term 1 divided by n square expected value of summation I is equal to n x I minus mu whole square plus 2n2. This term is covariance term. We can write n minus 1 covariance of xi minus ij. We can write, yeah, xj. We can write xj. This is the covariance term. We can write in this form. So the sampling is with replacement case. So the sample are independent. So the covariance term is also 0. As we know that the sampling is as we know that sampling is with replacement, here xi and xj are independent events. So covariance between xi and xj are equal to 0. So in the place of we put this term, we put 0. In place of this term, we put variance of x bar is equal to 1 over n square expected value of summation I is equal to n up to xi minus mu whole square plus 0. Here 0 multiplied by something, this will be, we will get 0. Now this term, if we are expected value we are use here, so this will be get n square, n sigma square. So we can write this one 1 over n square summation we change into n, and expected value also applied, expected value of x bar minus xi minus me whole square. Now this is cancelled to each other, here 1 divided by n, and this term is we can write n sigma square, n sigma square divided by n sigma square, n sigma square, sigma square, that is also sigma square, and we get here sigma square divided by n, which is the required proof of variance of x bar is equal to sigma square x bar is equal to sigma square divided by n, which is the required result in case of with replacement. Thank you very much for watching. Appreciate you in advance. Please subscribe my channel.